So I want to talk about differential equations. So I guess here I won't talk about PDEs, I'll just talk about ODEs. So ODEs are ordinary differential equations where I guess just for interest I'll say that PDEs are partial differential equations. So what I'll say is that basically really the importance of ordinary differential equations is there's some sort of function, let's say f of x. It's important that this is just a function of one independent variable. So basically what we can say is, okay, we're trying to observe some sort of phenomena, okay? And we can say something like, well, I don't know what f of x is, but I can start making relationships with it. So maybe, for example, it's the case that f prime of x equals f of x. This is the most general differential equation, but what's interesting about this is that I've related f of x with its derivative, and this is what you call a differential equation. So you're trying to find, you know, you're trying to find a function that satisfies this ordinary differential equation. And there's actually a lot of theoretical questions here, you know, because one thing is that is this unique? That is there a unique solution? So if I just look at this, I could say f of x, equals 0, or f of x equals e to the x, because the derivative of 0 is 0, and derivative of e to x is e to the x. So look at that. I found two solutions to the same differential equation. If I say something like f of 0 equals 1, well, f of 0 here is not equal to 1, it's just equal to 0. But for the second one, that's equal to 1. So I put a condition, we call this an initial condition, and I find that this is a solution. So really, the way that differential equations work is that you have an equation that's all dependent on, you can basically write any differential equation as, let's say we have some new function phi, and we have fn, which is the nth derivative, and we have that go down to just f of x and x. So you can write it like this. So it's basically saying that you can write a differential equation as containing all of its derivatives plus its independent variable. So for this video, this will just be an intro video, but the name of the game with differential equations is it gives you a manner to find a function that has the behavior that you're looking for. So you could say something like, we basically you basically want to catch some sort of phenomena. So you write an OD. Hold on, pen messing up. So you basically write the ODE that represents what you're trying to capture about your quantity. And then we're interested in finding the solution and then checking it. That is, if it's an analytic solution. So there's really two ways we go about solving ODEs. So there's the analytic, which is find f of x, using our previous notation. Or you can find f of x numerically. So what do I mean by that? So if you find f of x, I'll be able to graph that guy, right? So basically, if you're trying to numerically find f of x, let's say f naught of x, so this is trying to find the numerical solution that is approximating f of x. Well, we come up with methods, we call it numerical analysis, where we find discrete points for the independent variable, which would be x, and we basically try to approximate the value at each one of those points. So, and if we do a very good job, we'll basically numerically find it, even though we won't have, we won't have the case that f of x equals e to the x in the numerical case, but at discrete points that we pick, we'll say x0 all the way to up to xn, we'll know the value of it at discrete points, and we're interested that basically, hope I don't run out of room, basically f0 at some x star, one of the discrete points, minus f at x star, so really the approximating value minus the true solution is small. It's less than some small quantity. So overall, in closing, the idea of differential equations is to find a solution to this problem, which in the case of something like, if we look at something like 5x equals 10, the solution is 2, it's algebraic. But if I look at, for example, f of x equals f prime of x equals f of x, with f of 0, let's say, equals 1, well, if I get this guy, the solution is a function. It's a function instead of a number. So we're really interested in finding the function that satisfies a differential equation, the same as we're interested in a number that satisfies an algebraic equation.